knows a lot about the science stuff. Professor Dave explains.
In the previous tutorial, we covered the first 4 classes of minerals, those being native elements, oxides, halides, and sulfides. The other 4 mineral classes that we will discuss can all be described as oxyanions, or minerals with polyatomic anions composed of some atom covalently bonded to oxygen atoms. The most important class of these minerals by far is the silicates, but these will require several tutorials unto themselves. There are 3 other classes of minerals containing oxyanions, those being the carbonates, sulfates, and phosphates, so these are the ones we will focus on here. Carbonates are minerals that contain the carbonate anion, CO3 and this is a representative group for other similar anion complexes such as nitrates and borates, the latter being a bit more complex. Carbonates are commonly found in biogenic sedimentary rocks and evaporite deposits, or rocks composed of minerals formed through the evaporation of natural waters. The most common carbonate mineral by far is calcite, or calcium carbonate. Moreover, calcite happens to be the most abundant non-silicate mineral in the crust. There are actually 2 forms of calcium carbonate: calcite, which is in a rhombohedral form, and aragonite, which is in an orthorhombic or rectangular form. Limestone is composed primarily of calcite, which is soluble in acidic solutions like rainwater. Hence, areas with limestone bedrock commonly form large cave systems, such as Mammoth Cave in central Kentucky. Limestone caves typically have large deposits of calcite crystals located throughout, known as speleothems. They include stalactites, stalagmites, and flowstone. Speleothems are formed by groundwater that degasses or releases dissolved CO2 upon entering the cave's atmosphere, which is typically aided by agitation through such processes as flowing over a rough surface or dripping onto the floor. The carbonate minerals are a fundamental component of the carbon cycle, representing an enormous sink for atmospheric carbon dioxide, especially when they form in the ocean and sink to the bottom. More on that in the upcoming ecology series. Sulfates contain the sulfate anion, SO4 and this is a representative group for other similar anion complexes, such as selenites, chromates, and molybdates. Gypsum, or hydrated calcium sulfate, is a common sulfate mineral that has been used for building and construction since ancient times. The fine-grained variety of gypsum, called alabaster, appears in canopic jars from ancient Egypt. Gypsum can be dehydrated into anhydrite, or calcium sulfate, when heated, and the 2 minerals are often closely associated. Like calcite, gypsum and anhydrite can be precipitated from evaporating seawater and dissolved out of bedrock to form large caves. Phosphates contain the phosphate anion, PO4 This class is also representative of other similarly structured anionic complexes, such as arsenates and vanadates. A commonly encountered group of phosphate minerals is the apatite group, which has the chemical formula Ca5PO43X2, where a combination or pure fraction of chlorine, fluorine, and/or hydroxyls can fill the X site. When a combination of one or more elements can fill a specific crystallographic site in a mineral, it is called solid solution. Hence, it is said that there is solid solution between each end member of the apatite group, those being hydroxyapatite, chlorapatite, and fluorapatite. Much of your daily calcium intake from foods and vitamins goes toward the construction of hydroxyapatite for your bones and teeth. In geology, apatite can be an accessory mineral in igneous rocks or a component of certain sedimentary rocks that are rich in skeletal fragments like fish bones. Our final class to discuss is the mineraloids, which are not really minerals since they are not crystalline. Since mineraloids are naturally occurring substances found in rocks, they are often mistaken for minerals. Some examples include opal, which is amorphous hydrated silica, and obsidian, or volcanic glass. Obsidian forms when a felsic lava is rapidly cooled, leaving insufficient time for the atoms to migrate to form a regular repeating structure. Remember when we talked about silicious ooze in the tutorial on oceanic crust? Well, opal is what silicious ooze transforms into with time, and over even more time, opal converts to microcrystalline quartz, forming the sedimentary rock chert. So that covers 7 out of the 8 classes of minerals, plus the mineraloids. The one class that we haven't covered yet, silicates, will have to be covered separately due to its abundance and importance. So let's move forward and check out silicates next.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.